All right, so if we look at this, we've got a lot of powers of 2. And again, you don't have to memorize them. It's just good if you're familiar with them. So we want to fill them in. 2 squared is 4. 2 to the third is 8. 2 to the fourth is 16. And essentially, we're just multiplying everything by 2 as we go down the list. And those are the numbers that we get there. And you can use your calculator to do these, but when we get into simplifying these rational, these problems with rational exponents, sometimes it's good to just say, okay, I think I've seen that number as a power somewhere. Let me go look back at my list. Or again, calculators are also an option. But we just want to be familiar with these numbers. Sorry. Me trying to do math in my head and talk at the same time. It's not working. Then you have just a few powers of 3 and a few powers of 4. And do you notice how 2 to the 10th and 4 to the 5th are the same number? Because isn't 4 a power of 2? Right? 2 squared. So it's like half. 2 to the 10th and 4 to the 5th, the exponents are half, but it's the same value. That's because 2 is twice what 4 is, or 4 is twice 2. Anyway. And then we have 5 squared is 25. 5 to the third is 125. And 5 to the fourth is 625. Then 6 squared is 36. 6 to the third is 216. 7 squared is 49. 7 to the third is 343. 8 squared is 64, and 8 to the third is 512. Everybody go with that? All right, just a few more common powers. These are just some larger numbers being squared and cubed. So if you will, take a minute and... All right, so let's see, 9 squared is 81. 9 to the third is 729. 10s are real easy. All you have to do is put a 1 in however many, or whatever the exponent is. That's how many zeros you put. 11 to the third is 1331. Is that right? 1331. Okay. 12 squared is 144. What is 12 to the third? 1728. Thank you. All right, and then the squareds. 13 squared is 169. 14 squared is 196. 15 squared is 225. 16 squared is 256. 17 squared is 289. 18 squared is 324. 19 squared is 361. And 20 squared is 400. Okay, those numbers are also good to be familiar with, the higher squares. We don't see those a lot, but just in case. And again, don't have to memorize those, just there for you to use. And also to say, I think I remember seeing that number on one of my lists, so it's a power of something. So the first thing we want to do is we want to remember about negative exponents. Okay, just a reminder, because we've talked about this before. If I have some base to a negative exponent, that changes its location, not its sign. Remember, we did our exponents, and we would always write them without negative exponents. So x to the negative n would be 1 over x to the n. It changes where it is in the fraction. It doesn't change the value of it. And then this is what rational exponents look like. You have some base, some number, raised to a fractional exponent. Okay, our exponents are now fractions. So some base b raised to the p over q power. Some base b raised to the p over q power. And here's how this works. That denominator, that q, if I can get my pen to write, would be nice, is the root that, come on, is the root that we take. So if that denominator is a 2, we're going to take a square root. If that denominator is a 3, we're going to take a cube root. If it's a 4, we take the fourth root. And then that top number, the p, is going to be the power that we raise that number to, which is exactly what I have symbolized over here. We take the q root of b, oh, come on, the q root of b, and then we raise it to the p power. Thank you. Now, why are these tied to radicals? I want to show you something. If I had this, oh, come on. If I have the square root of x, okay, and I wanted to rewrite that with a rational exponent, it is going to be my x is my base. What root did I take? The square root. So my denominator is going to be a 2. And then what power did I raise it to if there's nothing out there? A 1. So the square root of x is the same thing as x to the 1/2 power. So if I had the cube root of x, what do you think that would be? X to the 1/3 power. Okay, so they can either be written in radical form or they can be written in exponential. That's the rational exponents that we are talking about right now. Now what we're going to do is we're going to start simplifying numbers raised to fractional exponents. The denominator is the root that we take. The numerator is the power that we raise that to. Everybody ready? All right, let's take a look at number 1. We are going to do 9 to the 1/2 power. So my denominator is the root that I am going to take. What root am I going to take of 9? The square root, yep. And then I'm going to raise it to what power? The first. What is the square root of 9? 3. And 3 to the first power is just 3, right? That's all you do. You take the denominator root, raise it to the numerator power, and that is how you simplify. So for number 2, what root of 27 would I take? Cube root. And then I would raise it to the what power? Sorry, my pen's not working right. What is the cube root of 27? Shaking it like it actually is going to do anything. And then 3 to the first power is 3. I'll take my battery out. Go ahead and try 3 then. What root am I going to take here? The fourth root. And then I'm going to raise it to the what power? First. What is the fourth root of 16? And 2 to the first power is 2. So far, so good? Okay. All right. I want want you to try 4 and 5. Remember, the bottom number is the root you take. The top number is the power that you raise it to after. And the reason we take the root first and then raise it to a power is because I don't want to get some large numbers. I could technically do it backwards. I could raise it to the power. So like I could do 16 to the 3rd power and then take the 4th root of it. But that just gives me extra large numbers and I don't want to deal with those. So it's better to make it small first by taking the root and then raising it to a power. All right, what root am I going to take for number 4? 4th root, and then I'm going to raise it to what power? 3rd. What is the 4th root of 16? And 2 to the 3rd power is? 2 times 2 times 2 is 8. All right. All right, what root of 81 am I going to take? Square root, and then I'm going to raise that to the 3rd. What is the square root of 81? And 9 to the 3rd is? There you go. Anybody have any questions so far? Okay. We're going to change it up just a little bit. This time I have 25 to the negative 3 power. So we have to remember about our negative exponents. The process is still the same. What root am I going to take of 25? The square root. Okay. And then I'm going to raise that to the what power? Negative 3rd. Well, what is the square root of 25? And this is where remembering what we did with negative exponents a while back is going to come in. I don't multiply 5 times negative 3, but I need that negative 3 to turn positive, and to do so, where do I move the 5? At the bottom, and I'm going to put a 1 at the top. And when I move it to the bottom, that 3 becomes positive. So what would my answer be? 1 over what? 125. So combining some stuff that we've already done with this new stuff. Is everybody okay with that so far? Okay. I want you to try 7. We're going to have to talk about 8 and 9. Okay, go ahead and try 7. And then we're going to need to talk about 8 and 9 because they're a little bit different. What root are we going to take for number 7? The cube root, yeah. And then we're going to raise it to the negative 2 power. What is the cube root of 8? 2. So 2 to the negative 2, what does that become? 1 over 2 squared, which is 1 over 4. Yep. So far so good? Now, what I want to do is focus on 8 and 9. Do you notice how they're almost... Whoops. What did I just do? Hello. There. Try that one more time. I don't know what just happened there. Do you notice how they're almost exactly the same? What's the difference? One has parentheses and one does not. So we need to think back to when we were dealing with exponents. Remember we talked about if the negative was inside the parentheses, you would carry it with you as you simplify. And if it's not in the parentheses, then you simplify and just put the negative in the answer. Okay. So with this one, with number 8, my negative sign is not in the parentheses. So technically, this is negative 1 times 36 to the negative 3/2, which means I need to simplify that 36 to the negative 3/2 power first, and then multiply it by negative 1. That's because the negative is not inside the parentheses. So therefore, it does not go with the 36 as I simplify. So let's work on this. I'm going to keep that negative 1 out here. What root of 36 am I going to take? Square root. And then I'm going to raise it to what power? Negative 3. Okay. What is the square root of 36? 6. Then 6 to the negative 3rd is going to become 1 over 6 to the 3rd, right? Which is 1 over how much? 216. And then I just multiply that by a negative 1, and so I get negative 1 over 216. So far, so good? With 9, my negative is inside the parenthesis. That means I'm going to carry it with the 36 as I simplify. What root am I going to take? Square root, but I'm taking it this time of negative 36. And then I'm raising that to the negative 3rd power. What's the problem? I can't do a square root of a negative number. I can do a cube root or a 5th root, but remember when we talked about the radicals earlier, because we haven't gotten to the imaginary number yet, if I have an even index, a square root or a 4th root of a negative number, we cannot do that, which means I cannot go any further. So what do I put for now? You guys remember what we called it? Not real. Okay. Because I cannot take a square root of a negative number. I can take a cube root and I can take a 5th root, but I cannot take a square root. So far, so good? Okay, I want you to try those two for me. Whoops. Try those two for me. Same concept, except for my denominator's changed a little bit. Keep in mind, if the negative is inside the parentheses, it is carried with the number as you simplify. If it is not inside the parentheses, then it is just held until the very end. For number 10, what root am I going to take? The fifth? Is the negative go with me or wait till the end? Goes with you. Can I actually take the fifth root of a negative number? Yes. Can't take a square root or a fourth root, but I can take a cube or a fifth. What is the fifth root of negative 32? Negative 2. And then that is going to be raised to the negative 1/3 power. I'm sorry, to the negative 3 power. So to make that 3 turn positive, I'm moving that negative 2 to the bottom. If you notice, did I change the sign of that 2? No, I just changed the sign of the exponent when I moved it. And then I need to figure out negative 2 times negative 2 times negative 2 is what? Negative 8. So we should get a negative 1/8 for our answer there. Is everybody okay with that? All right. 11. Same thing, except for this time my negative is going to stay until I'm finished simplifying. Whoops. So when I take the fifth root, it's just of positive 32. You told me the fifth root of 32 was 2. 2 to the negative 3 is 1 over 2 to the third, which is 1 over 8. Did we get the same answer this time? We did, right? We got a negative 1/8, wherever the negative is, as long as it's in the answer. The reason is because that was an odd root instead of an even. Anybody have any questions? We got 2 more. You know, I got to throw some fractions in here on top of the fractional exponents. It's the same thing. We've got the fraction 4 over 9 that I'm raising to the negative 3/2 power. We do exactly the same thing. We just do it to the numerator and to the denominator. So what root would I take of both of these? Square root. So I'm going to take the square root of 4, and then I'm going to raise it to the negative 3rd power. And then I'm going to do the same thing to the denominator. Take the square root of 9 and raise it to the negative 3rd power. I do exactly the same. It's just I have 2 pieces that I have to do it to. What is the square root of 4? 2. So I've got 2 to the negative 3rd, and the square root of 9 is 3, also to the negative 3rd power. I cannot leave negative exponents in my answers. Where is that 2 going to go? To make that 3, it's going to go to the bottom, right? Whoops. And then where's the 3 at the bottom going to go? To the top. So basically we just switch those. What is 3 to the 3rd? And 2 to the 3rd? 8. Go ahead and try 13. Same exact thing. Just take the root of the numerator and the root of the denominator, then raise them both to the same power. Just make sure in the end that you completely simplify. Yes. You got something to pick up and student affairs. Okay. Does the negative go with the 8 as you simplify, or wait till the end? Probably. Go with it? Yeah. Take it with it as you simplify. We don't have homework, right? No. What root am I going to take of both the numerator and the denominator? Cube root. Here we go again. Cube root of negative 8, and then I'm going to raise that to the 2nd power. I'm going to take the cube root of 64 and raise that to the 2nd power. What is the cube root of negative 8? And the cube root of 64 is 4. What is negative 2 squared? Negative 2 times negative 2 is positive 4. Maybe. Try this again. And then 4 squared is 16. Should I leave my answer like that? No, because 4 over 16 can reduce all the way down to be 1 over 4. Did anybody catch trying to simplify early? You could have. You could have simplified in the beginning, that 8 and 64. You would have still gotten to the same answer. Okay, you just have to be careful with that.